Not at all. Yes, you can hear me well? Okay, perfect. Thank you so much. Good afternoon, everyone. It's a pleasure to see actually so many of you here in the room. And welcome to our side event debating marine carbon dioxide removal, balancing challenges, risks, and future needs. My name is Marine Le Cerf, and I work as head of international policy within the Ocean and Climate Platform. And well, I have the utmost pleasure of being your moderator today. Before we dive in, let me just take the time to thank the co-organizer of this session, the Plymouth Marine Laboratory, for their great help and support in convening this event. So thank you, Tekla, and also we'll have Ellen joining us online. I'm also taking the opportunity to thank the different organizers and conveners of this pavilion. It's been 3 years now that we're all together, so thank you very much, especially to Woodsell and the Scripps for convening us here. And since we're reflecting over the last few years, let me just take a moment to go back to COP28 in Dubai, where we concluded the first ever global stocktake. And actually, like this atmosphere, which is a bit difficult now in the discussion, the conclusion of the global stocktake were very sobering. We are not on track to meet the goals of the Paris Agreement, and we also found out that the window of opportunity to get back on track is closing rapidly. So this puts really in the spotlight the technologies that could increase the ocean's uptake and storage of carbon that we know as marine carbon dioxide removal. And I'm sorry for this, but I'm going to be using the acronym for the whole discussion, so mCDR. Several techniques exist, from ecosystem restoration to ocean fertilization or alkalinity enhancement. But you will hear this from our panelists very soon. I'm not a scientist, so I will leave that to them. Let me just provide some context for the debate, because yes, this is a deeply divisive issue, and we want to address this as really a discussion. So on the one hand, we have advocates of deployment arguing that marine CDR techniques could contribute to climate mitigation objectives, so really trying to keep the 1.5 degree alive. On the other hand, opponents argue that there are still too many unknowns around these techniques, particularly when it comes to efficiency and to the potential negative impact it could have on ecosystems and societies. So to delve a bit more into this debate, the Ocean and Climate Platform organized 2 workshops this year. The first one brought together experts from the Ocean and Climate Platform Scientific Committee, as well as some additional experts, and many of these experts are actually on the panel or in the room. And it really aimed to review and clarify the current state of knowledge on marine carbon dioxide removal, and really trying to identify the research gaps and research opportunities. And the second one was more discussing with our members about key areas of consensus and disagreements, drawing upon these different scientific conclusions that we are here today to discuss. So I can share already with you our 3 main priorities and conclusions on which the network agree. The first one, and I cannot stress this enough, it is necessary to prioritize decarbonization measure. Marine CDR techniques should not be, in any case, a substitute for emissions reduction. The second one, and again, this is very important, we need to safeguard the integrity and functioning of ocean ecosystem, as well as their contribution to human well-being. So I'm talking here about ecosystem services, basically. They should not be compromised by any kind of marine CDR activities. And the last one may seem like something very easy, but we don't always think about it, is to ensure an equitable distribution of the benefits, but also the cost of mCDR activities, to make sure that we prevent any harm, especially to marginalized communities, including indigenous people and local communities, because as we all know, the impacts of marine CDR are transboundary by nature and are most likely to impact these communities. So it's essential that also their rights, and as well their knowledge, of course, are respected. Of course, we started this discussion and there's still a lot of issues that remain unresolved. For instance, the question of which mCDR technique should be prioritized, or the question of timing, because as we know, there's more and more projects, we are getting more and more investments into these activities, but at the same time, independent research cannot keep the same pace, right? So these are the things on which we would like to hear a bit more about today. And to do that, we have a fantastic panel of experts that will help us navigate this very complex and difficult debate. So we will be focusing on three main points: the potential efficiency of these approaches, their associated risks, and the necessary safeguards for responsible research and for potential deployments. So let me introduce this fantastic panel here. We have Dr. Hans-Otto Partner, the co-chair of Working Group 2 of the Intergovernmental Panel on Climate Change, specifically for the 6 assessment reports. And I think I have slides with everyone, so yeah, here it is. We also have Professor Lisa Levin, who's a professor emerita at Scripps Institution of Oceanography. Then we have, and I don't know if we can have her directly on the screen, that would be perfect. We have Professor Helen, fantastic, Helen Finlay, one of our hosts for today, joining us online. And Helen is a senior scientist at the Plymouth Marine Laboratory. Thank you for being with us from the United Kingdom. And we also have Honorable Janice Lachance, easier name to say for me as a French person, who's the interim executive director and the CEO of the American Geophysical Union. And last but certainly not least, we have Dr. Lucas Marks, a postdoc investigator on marine chemistry and geochemistry at the Woodsole Oceanographic Institution. So thank you for being here, and I suggest we give them a big round of applause just to warm us up. All right, since time is limited, let's just dive right in, okay? My first question is really about the where do we stand? So I would like to start actually with you, Hans-Otto. If you could explain a bit more about these different techniques, how efficient could mCDR techniques be in mitigating climate change? And how is this efficiency measured? Thank you. And you should have a mic.
Okay, thank you. Thank you very much, Marine, and thanks a lot for the honor of being on this panel. And you're asking some crucial questions. How can we ensure that these methods are efficient and actually do what we would like them to do, and what kind of research there still needs to be done in order to make this happen. And if you ask about efficiency, then certainly the first one is about what a chemist would call stoichiometry, in terms of how much CO2 is actually bound for and by those techniques, and whether we can prevent another process, that is remineralization, which is a remobilization of the CO2 from the carbon stored in sediments, in organic residues, and so forth. And then certainly the question for me, if I would include here, to what extent we need continuous human effort to make this happen, or whether it's a one-time effort to actually do this. And last not least, it's a financial question. If there is a continuous human effort needed, then this means there is a continuous cost on top. That is financial cost, there's an energy cost, and so forth, that we need to be aware of. In terms of side effects, I would actually also include this in any consideration, because the question is to what extent we are allowed, and this is an ethical question, to add substances to the ocean at large scale, because that is what it entails. If we want to really have large scale contribution of mCDR, then we need to work with the ocean on large scale. It's not just a regional activity, and there is where for me currently the bucket stops, in terms of if we add material that we never get out again once we have the climate under control, then this is a problem. And it's a problem because we will not be able to really assess to what extent this is a benign effort or not. So a big question mark, and these are open questions that we cannot yet fully answer with respect to these processes. I may also briefly refer to what the IPCC has said about these processes, and they are considered in terms of their capacity, but the capacity there is largely considering the rate of how these processes can contribute, and that rate is small compared compared to what the land-based systems currently contribute. Okay, this consideration does not include yet the possible technical use of mCDRs like alkalization, but it refers to the blue carbon system. So I think we as ocean people, we would our best bet currently is to say, let's work with the natural ecosystems, let's join forces with the biodiversity initiatives that are strengthening ocean biodiversity. That immediately means also strengthening the natural carbon cycle, strengthening the stores, the natural carbon stores that are available. And with respect to any other activities, let's be very careful, because as you said very rightly, they are not replacing in any way our efforts to curb emissions. That should be high priority. But in the long run, CDR and especially blue carbon systems can make a contribution to stabilize the climate, and for that we urgently need to protect and restore ecosystems.
Thank you very much, Hans. I like that you bring in the moral dilemma perspective as well. I think this is a question that we should all ask ourselves. Is it something that we want to do, that we should do? I think this is part of the discussion and should always be brought back into the debate. So thank you for that. I also like that you put back the difference between the different techniques as well into the discussion. I think there's a lot of blue carbon people in the room, and it's always important to also make the difference in terms of the technique, that some can actually bring strong co-benefits in terms of adaptation, resilience, and biodiversity conservation and sustainable use. So it has to also be a part of the debate. And so far, the IPCC definition of these mCDR techniques really cover the whole range of mCDR techniques. Thank you very much. And talking about biodiversity, it's actually making my life easy in terms of transition. And moving to you, Lisa, perhaps you can explain a bit more about the main ecological and social risks that are associated with the implementation of mCDR. And I know you have a presentation, so just give me.
Is this on? Yeah? You can hear me? Talk without this. Okay. So after 40 years of teaching, I need slides to guide me. So I was asked to talk about the ecological and social risk. And I think it's fair to say that almost all the varied mCDR approaches act to accelerate or enhance some natural process, but these pose the risk of altering ecosystem balance and integrity in surface waters and in the deep ocean when they're applied at a scale large enough to actually affect the climate. So the deep ocean is the repository for a number of the mCDR technologies. And I think it's important to realize whether it's the surface or the deep, these disruptions are likely to impact people. These changes to the ecosystem are likely to impact people whose livelihoods or dwelling or spiritual well-being depend on the ocean. So I've grouped sort of some of the environmental impacts together. A variety of the technologies that stimulate phytoplankton growth or grow macroalgae will change albedo, that is the reflectance of light from the surface. That affects the warming of the ocean. They'll also affect how much light can penetrate down into deep water, and that'll affect animals which respond daily to changes in light and how far they migrate vertically and so on. There are other technologies like direct carbon capture or electrochemical ocean alkalinity enhancement, alkalinity that actually just entrain massive amounts of water. And these lead to loss of larvae, for example, and could affect local and coastal fisheries. most of this hasn't been quantified in any real way, but I'm just covering some of the major categories of impacts. There are changes in nutrients and production pathway that would result from iron fertilization, but also from extensive macroalgal culture. Sometimes this means redistributing nutrients. If we draw them down in the Southern Ocean, they aren't available in the tropics for fisheries production. Due to connectivity of the ocean. If we put nutrients into macroalgae, they're not available to the phytoplankton-based pathways that might fuel important fisheries. When you have large stimulation of phytoplankton growth, it sinks and decays, and that microbial decay consumes oxygen and releases CO2, and that creates zones of deoxygenation and acidification underneath the process. And all of those affect species distribution. Some animals avoid them. This leads to biodiversity loss. It changes food webs. It changes vertical migrations and potentially the natural cycle of carbon sequestration. And then acidification, which can result from that process I just described, or even from CO2 injection subsurface, which we know can leak out into the water. So all that addition of CO2 can lead to changes in calcifiers, shellfish, but also fisheries well-being, and ultimately people and their livelihoods. Some of the technologies release toxins like metals or even pesticides if you're sinking terrestrial agricultural waste. So there is ocean alkalinity enhancement and addition of olivine and some of the other mineral compounds come with metals like cobalt and nickel. So again, the risks of contamination. And then when you put a bunch of organic matter or organic waste onto the sea floor, or even stimulate massive phytodetritus falls, you risk smothering the sea floor. And those ecosystems down there, they're not flat, featureless. They are full of life, sometimes full of fish, sometimes full of other ecosystems that filter or sequester or enhance the health of the ocean. So we just need to be very cognizant. And so my final message is that there is a major need to evaluate at scale ecosystem and social risk of mCDR for both the planet and for the people on the planet.
Thank you very much, Lisa. This is very clear, and thank you for giving that many examples of the potential risk we are facing. So thank you very much for that. And that brings me actually to our next speaker, Helen Finlay from the Plymouth Marine Laboratory, who is going to tell us about some opportunities to actively evaluate and measure these risks. So if you could please put Ellen back on the screen, that would be perfect. Thank you. Okay, fantastic. Thank you, Ellen. Can you please, building on what Lisa was saying, explain us why it's so important to have monitoring, verification, and reporting, so MRV basically, to monitor and to follow potential mCDR development, and what are the big challenges that are associated to that kind of measures? Thank you.
Thank you, and thank you for having the opportunity for me to participate in this even virtually. So monitoring, reporting and verification, or MRV, refers to the methods which are designed to basically track the mCDR activities. And that means that we can work out how effective the mCDR is at storing, capturing and storing carbon, but also, importantly, is monitoring these environmental and social impacts that we heard from Lisa. So kind of combining what we've heard from Hans Otto and from Lisa here. So the first challenge is really defining what we mean by effective removal and storage, and also defining those acceptable limits of impact. And that's still very much a work in process. So the definition of durability is kind of interpreted differently. The IPCC has its versions, but other people have their versions. For example, afforestation at the moment is kind of have 40-year licenses. So a recent paper, for example, said that by Brunner et al. Said that for durability, for the carbon to actually be removed to neutralize the remaining fossil fuels under net zero emissions, we actually need to have storage of that carbon for over 1,000 years. So we're talking about really long-term processes, and to be able to make sure that we store that carbon away, we need to know what's going on with the system. So one of the challenges, again, is kind of located to the scale and location that we take these MRVs, and we apply these MRV, we apply these mCDR techniques. So if we're going into the ocean, the wide open ocean, then we've got a vast amount of area to cover to think about how we can monitor and verify that that carbon is going into the ocean and it's not having these detrimental impacts. We've also got to consider those natural processes. So carbon actually exchanges with the atmosphere relatively slowly across the sea surface. And we also need to know the baselines to be able to actually understand how we can see any change that we make on top of that. So defining those baselines is going to be really important in terms of the carbon, but actually also thinking about the biology and the ecosystem impact as well. What's going on now? What historically used to happen in terms of those baselines, in terms of carbon cycle? We've got environmental change happening, so how do we then detect any additional mCDR activities on top of that? And how do we really think about the reliably calculating those uncertainties and providing that so that we can make these carbon markets effective and succinct. So MRV is going to also be costly and challenging in the open ocean environment compared to on land because of the infrastructure that's needed to look at that environment. And the other thing is the difference between the open ocean system versus the coastal system. So the coastal system, which is where many of these activities may end up taking place because of the infrastructure needed for them, is firstly, it's a very spatially intense area. There's a lot of things going on. So one of the things that we need to consider and came up recently in a workshop we took part in was the fact that there's this spatial issue. How do we really balance the needs for these different activities that we're using the ocean for? But also the coastal ocean is very complex in terms of carbon cycling, other land-ocean interactions that can take place that influence that carbon. And so being able to detect any changes on top of that is going to be quite difficult. So we're going to require an integrated approach of kind of those in situ measurements using remote sensing, which is new technology, which is just kind of coming out in the most recent years. But also modeling is going to play an important role, I think, in moving forward with that. So I'll leave that there. Thank you very much.
Thank you, Helen. This is very clear, the need for really trying to measure, not only now, but in the long term, and really trying to have this follow-up of how do we develop mCDR technologies. And this is also echoing what Hans has said on the perception of the IPCC on the topic. And actually, going back to what you were saying, Hans, on the moral dilemma, we have with us, I'm sorry that the name is not the right one on the slide over there, but we are lucky enough to have Janice, the CEO of AGU, who just published a, let me get the name right, Ethical Framework for Climate Intervention research paper that can also help us navigate this dilemma and trying to see how we can ensure that the science that we're doing, the research that we're doing, is actually conducted in a responsible way. So if you could please tell us a bit more about this paper and what it entails, that would be fantastic. Thank you.
Thank you very much, Marin, and thank you all to the audience for being here. It's nice to see an overflow crowd for something this important. I'd like to start by giving you a very, very quick overview of the American Geophysical Union, which we fondly call AGU. We're an association that supports 500,000 Earth and space scientists in 192 countries in every part of the world. We publish 24 peer-reviewed journals. We convene meetings, including the largest gathering of geophysical and climate scientists in the world that will occur in about 3 weeks in Washington, D.C. We also provide career support and training, particularly focused on students and early career scientists. And we advocate for equity in the geosciences and for scientific ethics. And let me just agree with my prior speakers, my colleagues up here on the panel. First and foremost, AGU believes that aggressive action to reduce carbon emissions must be the primary strategy for reversing and addressing climate change. And last month, AGU released its ethical framework principles for climate intervention research, as was mentioned. It was developed over 2 years in partnership with a global panel of experts in climate science, technology, ethics, and public policy. And it builds on some earlier efforts, guiding principles specific to climate intervention, and it draws heavily from ethical precedents developed for biomedical research and genetic engineering. Similar fields where the stakes for humanity and the environment really are profound. The framework outlines 5 key principles. Let me go through them for you. First, responsible research. Researchers should provide a clear, public justification for their activity. They should not only assess the direct risks, but also the physical, environmental, and social consequences if their research is scaled. Second, climate justice. Before starting any activity, researchers should consider whether it would shift climate impacts from one group to another, as well as consider its impact on groups experiencing social, economic, climate, and environmental injustices, the impact on future generations, and on nature and biodiversity. The third principle is inclusive public participation. Researchers should have fair and inclusive processes to identify groups that may be impacted by the activity and include them in the discussion of the purposes and actual design of the research. They should secure the free, prior, and informed consent, especially of any Indigenous peoples likely to be affected. Fourth principle, transparency. Funding of climate intervention research and experimentation should be completely transparent. Researchers should handle data responsibly, report on the nature of the science involved, and document the decision-making process from start to finish. And lastly, the fifth principle, informed governance. For technologies with significant risks, funders should require independent review and approval of research proposals, with higher risk or large-scale activities undergoing even greater scrutiny. So the framework is not only grounded in science, but also heavily informed by the global community. We must ensure that the benefits and risks of these technologies are distributed fairly across all communities and that all voices have an opportunity to be heard. By discussing the benefits and risks of these technologies openly, we can advance responsible research and consider the potential impacts on marine ecosystems, coastal communities, and people and places, even those far from the ocean's edge, but still bound to its influence. We hope that you all will take a closer look at this and that you'll consider adopting this process as you enter this world if you choose to proceed with this kind of research.
Thank you very much, Janice, and I can only echo your call, so thank you very much for that, and I hope we can share also the report with those that are interested in the audience. Please come to us at the end. We'll be very happy to disseminate that for you. You covered a lot of different topics, and I think there's a lot in these principles, so hopefully we can dive deeper into some elements in the rest of the discussion. But I wanted to focus on one part, also to echo some of the work that we're going to discuss, specifically on inclusive public participation and transparency, and making sure that the communities and people that might be impacted on the longer, even in the shorter term, that might be impacted, are also part of the discussion, are also involved and consulted. So thank you very much for stressing that. And I'm now moving on to Lucas. You told me, if I'm not mistaken, that you're working on a project specifically in discussing this opportunity to have more public engagement involving communities in the development of specific mCDR projects. So I'd be very keen to hear more about that.
Thanks, Maureen. Thank you all for being here. Indeed, so I'm part of a research project which is focused on ocean alkalinity enhancement. And let me just start. I guess everybody in this room and around the world is aware of that climate change is the biggest challenge we face as humanity. So that includes the global economy as well as the global public. So in our research project, we actually embarked on a very serious and long-reaching outreach campaign, proactive in the sense of before we even do some research. And our research project is really designed to create baseline scientific foundation to inform legislation and regulations, because there's little to no legal framework set up for now. And during this outreach campaign, we talked to a variety of interested groups and stakeholders in this specific sphere, which included tribal communities, fishing communities, both recreational and commercial, regulatory authorities, as well as just the general public. And that was for us and is for us still an ongoing campaign. And this public outreach is so incredibly valuable, because we learned as researchers, we learned so much from those communities and implemented their concerns and their thoughts into our research design to complement and take them on board, because it's a societal problem we face. So we strongly believe that we need to include anybody who is potentially impacted or who faces some impacts. So by doing this, we could implement things in our research design which, as a scientist, we kind of overlook. And for example, fishermen have like fantastic baseline data and baseline knowledge about like specific regions, which we could, take advantage of in a sense to inform our like site selection, for example, for like a research trial. I do want to point out that science must lead the way in this sense, but science should be transparent and inclusive of public opinions and public concerns, because in the end, although the climate change crisis demands us to act very fast, but the research needs to be done first to create these baseline, standard knowledge base for even thinking about scaling up, right?
No, thank you very much. And I think we can all agree on the research and science first message. I think this is something we can all agree on. Perhaps I have a question for you, a bit to dive deeper a bit into this, to also ask you about the kind of challenges that you faced in this experience and how you try to overcome them. So to have more of a public engagement, transparency process.
So because we talk to a variety of communities, of course, none of them agree with each other. They all have different concerns, different interests. So first of all, it's a form of trust building at first, because we cannot just go to like one specific community, check a box, we did it, and then never return. So it needs to be a constant effort. Even after we did our research, we need to also be transparent about the results. May they be negative or positive. I want to make that very clear, that you need to convey to the public and any stakeholder or any interested party the outcome of a given research project. This trust building takes time, because there's a natural kind of not really opposition, but kind of distrust in science, at least definitely from fishermen, for example. So to get them involved takes a lot of effort. And from a personal point of view, it's not nice to be screamed at for 2 hours. So, but we willingly, in our project, we willingly do this because we feel it's like highly important to hear any voice involved in this situation, in this kind of research, because every voice demands or like deserves to be heard and should be heard to be to have this whole mCDR research and potential scaling up as a joint effort, really.
No, absolutely. Can only agree on the need to bring everyone together. And I can only imagine it must not be easy to bring everyone around the same table and have that kind of difficult discussion. And one point that I really appreciated about your presentation and what you said is also how you try to include it, because sometimes I feel like there's consultations and we're trying to involve the local actors, but in the end they don't really feel like they're being heard and they don't really see the way it's integrated into the work, shaping the work that you're doing. So making sure that also traditional, local, indigenous knowledge is part of this development is, I think, crucial. And that's bringing me back to you, actually, Janice. I would like to hear more about the different principles that you've presented, keeping in mind this idea of accountability, transparency, climate justice. You covered different points, so if you could please elaborate, that would be fantastic.
Sure. Well, let me start out by saying that the framework is voluntary. We're counting on researchers to adopt this and to think about how it can be incorporated into their work. But it goes beyond researchers. We're looking at a complete holistic community adoption of these principles. So first, let's talk about accountability. I thank you so much for that question, because these concepts aren't that far from what's already occurring across science, across other responsible fields that are trying to do their best to protect humanity and the planet. So the framework does recommend the establishment of independent review bodies for evaluating research proposals, especially when it's high risk or large-scale activities. But these mechanisms are in place for institutional review boards or similar ethical review processes. There's already examples of this being done successfully in other areas of science. Universities and research institutions have long histories of overseeing ethical compliance, particularly in the biomedical and social sciences. So the concept of oversight really isn't a bridge too far, but rather adopting what's already in place in other disciplines and applying it to this work that is being considered and actually being researched at this time. We also think that being accountable means developing and implementing clear mechanisms for reporting research outcomes and impacts. That's basically the peer review process at its best, which is the lifeblood of academia and journal publishing and scholarly publishing that many of you engage in regularly. So engaging diverse representative public institutions and stakeholders in your research has also become an increasingly important part of geosciences research and a key way to ensure accountability. So I'll give you an example just within AGU. We updated our journal authorship guidelines to promote equity and transparency in global research collaborations by encouraging the inclusion of local partners as co-authors when they meet authorship criteria, or at least acknowledging their contributions appropriately. So what we're trying to achieve there is to address issues like parachute science or helicopter science by fostering ethical and inclusive practices in international research efforts. So it's already being done. So this can be applied to the work that you're doing. And a lot of the private sector now and foundations and other funders are becoming increasingly involved in this field. And as they partner with academic community to advance these solutions, they also, we think, have a responsibility to implement accountability measures into their funding requirements to maintain public trust and credibility. We also think advocacy groups have a special role to play here. They are very well positioned to promote public participation and transparency by acting as intermediaries between scientists, policymakers, and the communities that may be impacted. We think advocacy groups empower communities by amplifying their voices, providing the necessary education and information, and fostering active participation in the decision-making process. These concepts have been championed and advocated for a long time, and they need to continue for this framework to be successful. Now, downstream, we're hoping that once this is in practice and incorporated into the research that's being done, we believe policymakers are going to be critical to creating and enforcing the standards that place those values at the core of decision-making and action. Policymakers can establish strong regulations and policies for climate intervention research that emphasize and ensure fairness, transparency, and inclusivity. So again, this is similar to existing environmental laws that are designed to safeguard public health, and the policies can protect vulnerable populations and ensure that no group disproportionately faces the risks associated with such research. So when you think about this globally, governments can work within international frameworks, such as the UNFCCC, to develop shared governance structures and try to avoid unilateral actions. So the bottom line, we think, is that the framework's principles contain many familiar concepts and practice, and they will lead to shared ideals, and we believe a shared commitment to fairness and justice and total transparency.
Thank you very much, Dennis. I very much like the fact that you bring other actors into the discussion as well. I mean, there's a lot of scientific organization in the room, and I mean, in the panel, I think this is pretty well represented. So I think it's also important to mention that there's other actors into the discussion. They need to, of course, consult and work with indigenous people, local communities, but also that the private sector is also already playing a role. So how do we interact with them? Also, it seems, this is a personal opinion, but that advocacy organizations have not been working so much on the topic. Everyone is still trying to get organized around it. So also how do we organize as a community to advocate on this topic, make sure that we have a coordinated approach to it, I think is very important. So thank you very much for that. And I've heard throughout the different presentations the word framework coming back very often, so I think this is also a very important point, and the need for strong regulatory frameworks at the national level are obviously very important. But I'd like also to zoom out a little bit, and also you mentioned the UNFCCC. I think there's the ocean governance, as we all know here in this room, is very fragmented. This is not a big news for anyone, but I think this is impacting very much the governance that we have on marine CDR at the moment. We have the London Protocol and London Convention trying to set a framework, but this is actually very limited scope, I believe, focusing mostly on ocean fertilization and also having some amendments that are not ratified at the moment, so not fully implemented. So there's still a lot of work to do on making sure that we're also aligning the different frameworks. You mentioned, as I said, the UNFCCC, but coming back from Cali and COP16, there's already some discussions there and some decisions that were actually adopted years and years ago to make sure that we don't have harmful geoengineering activities. So I think it's important to also see how we can strengthen this governance framework to make sure that if we are to develop this kind of technologies, we can make this in a responsible way. And that brings me to my next question, and that's to you, Lisa. You've been working extensively on deep sea ecosystem, and you have followed very closely the negotiations on the High Seas Treaty, also known as the BBNJ agreement. So I would love to hear a bit more about your thoughts on how this agreement can also help address the governance gaps that I mentioned and specifically strengthening the protection of the deep sea ecosystems.
Okay, sure. I think probably most people out there are familiar with the BBNJ agreement, which was signed last year, but it's in the process of ratification, and this addresses biodiversity conservation and sustainable use in areas beyond national jurisdiction. So the 60% of the ocean that's outside national jurisdiction. It's important to realize UNFCCC gives the states the rights to basically manage climate within national jurisdictions and their ships and so on, but it doesn't cover that vast area of the ocean. And so I think there are four main provisions in the BBNJ agreement, and every single one of these could be very important for marine carbon dioxide removal. The first is the establishment of environmental impact assessments for activities that are in beyond national jurisdiction, and it's important to realize that many of the mCDR techniques like iron fertilization, but probably others, will affect those areas, or they'll be done within EEZs, but the ocean is one connected area, and so the effects will diffuse out into international areas, or activities beyond national jurisdiction will diffuse into EEZs. And so it's really important that we have the ability to both highlight these activities, which the EIA provision will, and to set impact assessment standards. And these will be really important for any large-scale applications and the transboundary effects that I was talking about. Second major provision is the ability to establish marine protected areas in international waters. We can identify areas that have critical properties and functions that should be off limits to the disruptions created by mCDR. And I'll just say, although it's not about mCDR, we might want to include climate smart criteria in establishing these MPAs so that we can protect areas that are valued for their carbon cycle services and for carbon sequestration as well, which will help the climate. There's a capacity development and tech transfer component to the BBNJ agreement, and this is going to be super important to enable SIDS and LDCs and others to participate in mCDR research, to have input on the siting of experiments, and to continue to monitor and evaluate mCDR activities in their waters and internationally. And then the final component, marine genetic resources. We might not automatically associate that with mCDR, but it's quite likely that there are phytoplankton with exceptional carbon sequestration properties that we might want to use, and this could actually involve benefit sharing if those phytoplankton come from international waters. And another question in my head is whether we actually carry out mCDR for carbon credits in international waters, whether that the profits from that might actually need to be subject to benefit sharing with the nations of the world. So those are just some of the areas, and I'm sure there's many other important BBNJ applications.
No, thank you very much, Lisa. This is very helpful to see that there's actually concrete entry points on which we can build, for instance, as NGO organizations, as I was saying, in terms of advocacy. So really opportunities to build on and to also coordinate with other organizations. I mean, you mentioned digital sequence information, if I'm not mistaken, with the acronym DSI. and this is also something that is addressed under the Biodiversity Convention. So there is good entry points to also weave the blue thread across the different strategies. So thank you for that. I want to go a bit on the what's next kind of question, and for that I'm going to turn to you, and Soto, to ask you what you think are the next research priorities. And I mean, I said at the beginning it was one of the tough questions that remains, so sorry for that, but do you think we should prioritize some techniques over others? You already touched a bit upon that in your introductory remarks, so if you could perhaps explain the prioritization criteria, that kind of things, that would be very helpful. Thank you.
Yeah, thank you very much, Marine. This is a challenging question, and I'd like to build a bit on what we've said in our last assessment report in Working Group 2 of the IPCC, where we are proposing that we should take a holistic approach in terms of looking at the positive interactions between human society, natural ecosystems, and the climate, and strengthen those positive interactions. And I am doubtful that with respect to the measures currently discussed under mCDR, these fall under this title of positive interactions. So, but at least we should take a holistic approach to the system and think very carefully about what we are considering to be doing. And coming back to the point that adding substances that have not been in the ocean before, with all the side effects that Lisa has been describing, that this is something done long term may change the system irreversibly, and we need confidence. If we really want to do such a thing, we would need confidence that this does no harm to the system. And the question I have here is to what extent we can actually do research that gives us that kind of confidence. We have a baseline for those natural systems to function, and how do we make sure that, for example, by alkalization research, we are not changing that system long term, and then how long is long enough for the research to be carried out. So I think there could be some ethical considerations and considerations of feasibility before actually starting that kind of work. There's a large difference between that kind of research and, for example, the research we've done for years now in the field of ocean acidification, which actually started, just to mention that, as a spin-off from considering CO2 disposal, straight CO2 disposal into the ocean itself, and building CO2 lakes in the deep sea and things like that. I mean, outrageous considerations to solve a problem that humankind has been introducing elsewhere. So the research focus and picture must be holistic. It's not just about whether addition of some chemical has a short-term side effect or not. We may not have the resolution in that methodology in order to really gain that kind of confidence, and then set up large-scale research to how to strengthen the natural carbon binding capacity of the ocean, and actually, when thinking about that, how to secure this, to secure the carbon binding capacity of natural systems in the ocean. That's not a given. And as we are speaking, climate change is working on that. It's working on that capacity on land and in the ocean, and that should be our prime consideration in our research.
No, absolutely. I think it's always important to keep in mind that the ocean is already impacted by climate change, and that mCDR activities will be putting pressure in addition to what is already being done. So thank you for that. We're a few minutes late, but I think this is okay. I will just pass it on directly to Helen from PML to wrap us up the panel, and just building on what Hans said, explaining a bit more the role of mCDR or MRV, in this discussion, and explaining a bit how it would be implemented and how it could limit the impacts and make sure they are actually considered. So thank you, Eleni.
Thank you. I'll try and be brief given the time, but just to kind of build on Hans Otto, but also what Janice was saying and Lisa, there's frameworks already out there that I think we need to make use of and make sure that we're not just reinventing the wheel for the sake of it. So for implementing mCDR and MRV particularly, I think what we need to do is make it conditional in regulations and permitting. And in order to do that, we need to think about the indicators we need to be able to make sure that the regulators and the permits are actually be able to carry it out and be monitored. And so for carbon, that's things like this additional net uptake of carbon from the atmosphere into the ocean sink, whatever that is in terms of mCDR. So that's kind of, we need to really, again, coming back to understanding the baseline, what is it that we're doing on top of that? And then also coming back to the durability of that, how long are we keeping this carbon away? As we've heard from Hans Otto, this needs to be something that is really characterized well, and we understand where that is going, that carbon, and how long it's staying there for. But also when we're thinking about the ecosystem impacts, we need to think about the indicators that are relevant for those. So in the UK and Europe, and I think the US as well, we have quite well-established water quality indicators. And I think that's a really good place to start because the regulators are familiar with that, policy is familiar with that, and we're able to think about kind of the good environmental status that we want our oceans to be in. And so for them to be able to function effectively, we need to understand what that is. And so we can kind of use those, I think, to really make a good starting point to move forward with understanding what MRV and monitoring is required. So in terms of biology, it's really place dependent. So there might be some areas where we implement some of these mCDR techniques that are really, it's important that we characterize the phytoplankton, the chlorophyll, how is that manifesting through time. But there also may be some other areas if we have this in coastal environments where there's seagrasses or coral beds, which we need to be monitoring to make sure that those are functioning effectively as well. So I think we kind of need to have that dialogue as well between the regulators and the permitting as we move forward. So initially in this research phase, we need to be having that interactive discussion with them now. What is it that they already regulate? Is that adequate enough for MRV, for the mCDR techniques that we're talking about? Most of them don't seem to be from the work that we've been looking at. They kind of say that we have to look at pH, but actually we need to move beyond just pH, especially kind of thinking about alkalinity enhancement, things like that. But also modeling is going to be really important for moving forward to make projections of where we're going to do these things on big scales. And so looking at potential risks for environment, we need to understand what the locations are, where they're going to be, and what kind of biological aspects are going to be incorporated into those. So moving forward onto the kind of scale up, then we need to be, again, maintaining those dialogues and making sure that then once the regulators know what we need to be monitoring, they're actually able to implement those in their permitting. So yeah, thank you very much.
Thank you very much, Helen, and thank you to all of the panelists for giving us food for thought. I think we can give them indeed a big round of applause. Thank you very much for that. And I hope we can all continue this very important conversation all together. Before we close, I just have one final speaker to wrap us up. So I'm very happy, and I'm sorry if I pronounce the name wrong, but it's Dr. Melanie Jans-Singh, approximately this, sorry for that, who's the lead technical energy advisor of the government of the United Kingdom. So thank you very much for being with us, and I'll just let you close us up. Thank you.
Hello everybody, and thank you for this wonderful panel. I've been asked to represent my colleagues, so my colleagues have written this for you, and Kate Scott, Teresa Redding and Cameron Henderson. And it's just to give you a little taste of what we're doing on greenhouse gas removals and how that relates to mCDR in the UK. So firstly, the UK was one of the first countries to create a legally binding target to bring greenhouse gas emissions to net zero by 2050. Greenhouse gas removals, or GGRs as we call them in the UK, also known as CDRs, carbon dioxide removals, are an important component to reaching net zero, and we recognise that we might need to balance our residual emissions with greenhouse gas removals. The scientific community agrees that GGRs are essential for limiting the effects of climate change, and we agree with that. Our net zero strategy that we published in 2021 set out our commitment to developing GGRs at scale. And therefore, to meet our NDCs, the UK has an ambition to remove 23 megatons of CO2 per year by 2035. To put that into perspective, our emissions are around 400 megatons, potentially rising to 75 megatons CO2 per year by 2050, to help balance out our residual emissions. And in October this year, UK joined other world leaders in committing to the Accelerating Carbon Management campaign with an aim to achieve a gigaton of CO2 removal by 2030. The UK is continuing to develop and evolve its GGR strategy. So we don't necessarily have a clear one, but we have a plan and we're developing it. And we seek real evidence innovation and deployment of GGRs. So for this, we have a direct air capture and greenhouse gas removal innovation program. And these are the colleagues that I mentioned who wrote this for you. And they have provided around $75 million in funding greenhouse gas removal pilot plants for a broad range of promising technologies, including marine CDR. Our marine CDR innovation work is specifically, so there was one project, and it was specifically taking advantage of the higher capacity of seaweed to capture CO2 from the atmosphere, whilst carefully managing and monitoring any impact in the marine environment. As part of this funded program, the projects involved are providing evidence on energy efficiency and carbon capture, the level of reliance on transport and storage, flexibility in size and location, and alternative storage for the CO2 captured. We recognize the need to be guided by the scientific evidence on the impacts and efficacy of marine CDR, and it won't come as a surprise that these are the timing and volume of removals, the durability of these removals, the potential impacts on marine ecosystems, and robust ways to sanctifyingly monitor, report, and verify these. The UK is investing around $40 million USD in research funding on carbon dioxide removal field trials. Although that's a small component, research is being conducted on improving the growth rates to sequester of algae to sequester carbon dioxide in the atmosphere and understand the behavior of alkalinity added to the seawater. At a larger scale, with 11,000 kilometers of coastline, the UK is continuing to monitor the evolution of marine CDR opportunities and their supporting evidence. As part of our initial greenhouse gas removal strategy, we announced in October this year our commitment to fund $27 billion to fund carbon capture and storage projects across 2 carbon capture and use clusters on the east and west coast of the UK. Our greenhouse gas removal business model is being developed to provide a revenue guarantee to eligible projects, thus incentivizing private sector investment. So it's not just us. However, we did not include marine CDR in this as we recognize the need for further research. If you want to ask any further questions, please do let me know. But we continue to monitor developments and we recognize the need for further scientific evidence before really committing to marine CDR. Thank you.
Thank you very much. This was great. Thank you for sharing the national case study. We're coming to a closing, so thank you so much for attending. Let us know if you have any other question. I think we're all happy to follow up with you, and thank you for attending. And if we could take a picture all together.